Hey everyone, this is your friendly neighborhood math teacher, Mr. Bennett. Just going to go through the 2.4 lesson with you guys. As you can see, we're using kind of the similar experiment to what we did in the last class, right? We had those several experiments. We had the dice roller, we had the penny toss, and then the stopwatch. So we're going to use that stopwatch kind of activity. So in this top box here, it says in the stopwatch task from the previous lesson, we tried to stop it as close to 5 seconds as possible. Last year, the distribution of times for this task was approximately normal, with a mean of 5.02 seconds and a standard deviation of 0.10 seconds. So really quickly, I just want to make a quick note, okay, that the mean and standard deviation have new kind of symbols. We kind of briefly talked about those last time. The mean was the symbol mu. It's kind of the fancy looking U. And standard deviation was lowercase sigma, kind of an O with a little flare at the end. And so question 1 says label the values that are 1, 2, and 3 standard deviations away from the mean. So our mean, if we recall, is this center line. So our mean is in the center of our distribution. And so right there in the middle of our hill, we have our mean of 5.02. So now to the left and right, our first lines say 1 standard deviation and minus 1 standard deviation. So since our standard deviation is 0.10, to get there, we're going to add 0.10, which gives us 5.12. And on the left-hand side, we're going to subtract 0.10, which would give us 4.92. And so we're going to keep doing that each standard deviation. Every time I go 1 standard deviation, so from 0 to 1 and 1 to 2, 2 to 3, that 0.10 is the distance that we're traveling. So in between each of these is going to be an extra 0.10. So our 2 standard deviations would be at 5.22, and 3 would be at 5.32. And similarly, on the left-hand side, we'd have 4.82 because we're subtracting, and then 4.72. Okay, so that's what it means when it says 1, 2, and 3 standard deviations away from the mean. So question 2 then says what value is 1 standard deviation below the mean? So below the mean, our mean is here, below it is to the left. So 1 standard deviation would be 4.92. What value is 1 standard deviation above? Would be that 5.12. And then estimate the percentage of values within 1 standard deviation of the mean. So within 1 standard deviation means on both sides of the mean. So that's basically from here all the way to there. Okay, so how much of our data is in this really prettily sketched in area here, this pink area? So what percentage is that? Looks like quite a bit. Probably a little more than half. Maybe like, I don't know, 60 or 70%. So we'll just say about 70%. And then what value is 2 standard deviations above the mean? So if we look, 2 standard deviations was right here. We wrote down 5.22. Oh, whoops, below the mean. Sorry, so 5.22 is for above the mean. And below the mean would be 4.82. And then it says estimate the percentage within 2 standard deviations. So now it's that pink stuff plus all this green area in here. So now we're adding in all the way out to 2 standard deviations. And that looks like a lot of our data, right? If we look at it, there's a very little bit down here, very little bit down here. And so, that looks pretty darn close to most of it. So probably 90, 95%, somewhere in there. Again, we're just kind of estimating right now, so let's say 95%. And then question 4, what value is 3 standard deviations below, and what is 3 standard deviations above? So below is down here at 4.72, and above would be at 5.32. And so again, that's extending out from the mean. It's all the pink stuff, all the green stuff, and now including these little blue tails at the end. And, to me, that looks like all of it. I think we've basically filled in everything underneath our graph. So I'm going to say that looks like that's 100%. And again, this is an estimate. Like, we didn't actually verify that yet, but we're estimating. Okay, it's an approximation, so we're okay. Now, question 5 says to use this applet, and I'm going to tell you not to use that. I didn't change it in the notes because I thought maybe later on it'd be good to look at. Okay, but don't actually use this applet. I'm going to show you how to do this on your NumWorks calculator. So if you haven't grabbed a NumWorks calculator, go ahead and pause this and come back to it. Or if you want to just use the one on your iPad, that's fine. But we're going to go into our NumWorks calculator here. I'm going to show you how to do that. So I'm going to hopefully pull this up in my slide overview. There we go. So we're going to go down in our main homepage to the bell-shaped one that looks like distributions. So we're going to click OK, and then scroll down to normal, because it told us this was a normal graph. And it asks us to define 2 things. What is the mean and what is the standard deviation? So I'm going to go back up and just double check. So mean is 5.02. Standard deviation was 0.10. And then I'm going to click next. And it's going to take us to this page. You'll notice it has a graph that looks very similar to ours. The x-axis down at the bottom is a little bit different, right? We labeled ours a little bit differently, but that's okay. And so what it wants us to know is what is the actual percentage of values within 1 standard deviation of the mean. So within 1 standard deviation would be this pink area here, which means that I'm going, don't worry about that. Sorry, having a calculator issue there. Let's get rid of that. So we're going to go from this -1 standard deviation, 4.92, to +1 standard deviation of 5.12. So those are my 2 boundary lines because I want all that pink stuff in the middle. Okay, so how we're going to do that in our calculator, let me see if maybe split screen will work better there. Okay, let's try that. So we're going to go back to our distributions, 5.02, 0.1. And so I'm going to go to the left, and I'm actually going to change this little drop-down menu to this middle one. So see how the shading is kind of in between 2 lines there in the middle one? Kind of like how our pink is right now. So we're going to say that the lower boundary is that 4.92, and the higher boundary is going to be that 5.12. And if I click enter or execute here, it gives me this decimal. So this decimal gives me the percentage of that area. So that orange area that it's highlighting right now, the one that's kind of similar to the pink area we shaded in, that is the percentage. So that is 0.6827. So 0.6827, which if we turn into a percentage is 68.27%. And we're going to do a similar thing with our other two estimations here. So this is actual percentage within two standard deviations. So if I look at my two standard deviations, that was -2 was 4.82, +2 was 5.22. So I'm going to go back to my numworks calculator here. We're going to change our boundary from between 4.82 to 5.22. Oops, forgot my decimal. I'm going to hit execute. You'll see that it says 0.9545. So 95.45%. Then the actual percent within three standard deviations will be from 4.72, right? -3 is at 4.72, all the way to +3 at 5.32. So 4.72 all the way to 5.32. Trying to hit execute, gives me 0.9973, which translates to 99.73%. And so this right here is kind of a big deal. So what we just did, okay, is we, for a normal distribution, found that there was about 68% in between one standard deviation of the mean. There's 95%, right, roughly 95% within two standard deviations of the mean, and about 99%, almost 100% within three standard deviations. And so this stuff right here, all of this, is what is known as the 68, 95, 99.7 rule, or also known as the empirical rule. Which says that for any normal distribution, 68% of the data will lie within one standard deviation, 95% will lie within two standard deviations, and 99.7 will lie within three standard deviations.